Hello everyone, and how are you today? Now we've looked at two circle theorems. The first one, we look at chord circle theorem and also alternate segment circle theorem. Today we'll be looking at the third circle theorem. But I want to do a kind of recap first. If you have not watched all this in my video, please go and do so that you can get yourself informed, well informed. I want to let you know that the most important thing when it comes to circle theorem like this is ability for you to identify each circle theorem and to use appropriate words to describe them. And then when you have questions, you should be able to know which one of them or combination of them that relate to the question asked. Now let's look at the first one we've talked about, which is chord circle theorem. What do we mean by a chord? A chord is this line between 2 points on the circumference. And we are talking about minor chord here, not the major chord, which passes through the center, which we call diameter. So when we have a chord like this, if you draw a line from the center of the circle to bisect this chord, that is to divide it into two, it will do so at right angle. That is, this will be 90, this will also be 90. That is what the first theorem is saying, chord circle theorem. And then the second circle theorem is what we call alternate segment circle theorem. What do we mean by alternate segment? Now, this is a chord from one point to another, just like this. This is a chord. So this place is called segment, but it's a minor segment. The other places like this are called the major segment. And the major segment is also what we refer to as alternate segment. Now, if that is taken, what do we mean by tangent? This is the tangent here. The tangent is a line that is drawn and it touches the circle at a point. If it enters into the circle, it's no longer a tangent. Now, what is alternate segment circle theorem saying? It's saying that the angle that lies between this chord and this tangent is equal to the angle subtended by this chord in the alternate segment, that is in this other part. Once again, the angle that lies between the chord and the tangent, let's call that one theta, is equal to the angle subtended by this chord in the alternate segment. So which means theta here is the same thing as theta here. That is the second circle theorem. The third one that we'll be looking at today is called tangent circle theorem. And this tangent circle theorem is divided into two. This is the first one, and this is the second one. And what is this one saying? This one is saying that the angle between the radius and the tangent, the angle formed between the radius and the tangent is 90 degrees, which means this one is 90 degrees. That is what that is saying. Now, the second part of the tangent circle theorem, what this is saying is that if you have two tangents, this one and this is another one here, and then they meet at a point A, for example. Now, if that is the case, it means that this line AD will be the same thing as line AB. So which means this one and this one will be the same. Because already you know that from here to here is the radius, and from here to here also is radius. So if these two tangents meet, then this side and this side will be the same.